So we are going to start in June 23 and variant 41 and complete mechanics paper. So have a look. Question number 1. Two particles, P and Q, mass is m and 3. So, okay. So, one particle mass, this is a P particle, this is a Q particle. Mass is P is m kilogram and this is a 0.3 kilogram. So they are rest and smooth plane and P is thrown towards what? Towards this speed of 5 and towards Q, and after P and collide, P move with a speed of 2 and in the same direction as originally moving. So this is a before collision and I talk about after collision. So, and he's saying that P moves speed of 2, same direction. We need to find out the velocity of Q. So let's VQ is unknown. Okay, so let's try do it. Formula is M1 U1 plus M2 U2 is equals to M1 V1 plus M2 and V2. So this is zero speed we have. So 5 times to P plus 0 equal to 2 times to M and plus VQ times to 0.3. This goes there and 5M minus 2M and VQ times to 0.3. This is a 3 and divided by this divides and we get velocity 10. So this is a clear first part done. And now he's asking what second part. After this collision, PQ moves directly towards R. It means the third particle. And third particle, okay. And the mass is a 0.6. And which is at rest, and Q is brought to rest in collision with R. And R begins to move with speed of 1.5. So easy question, not hard. So we are considering okay. So what is the situation, students? We have now this is a Q and this is R. So mass is given here 0.3 and this mass is 0.6. And first of all, in terms of M, so just a minute, this is, I think I have to write this meter per second separate. Meter per second. Okay. So this is clear. And now Q is 0.3, we know it, and R is and before collision clear and after collision now. Okay. After collision, what he says? So this velocity we have already, you can see that 10m. So I'm writing here 10m. And this is 0 because it's a station in the beginning. And he's saying that when it Q is brought to rest, so this is rest, and R begins to move with speed of 1.5. Now, students, we can do it easily. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. So this is very clear. We can multiply. So 0.3 times 2, 10m plus 0. And here 0 and here 0.6 times 2, 1.5. And we can get it easily. 0.5 into 1.5 and divided by 3 because this goes down 0.6 into 1.5 divided by 3. 3 how comes? 0.3 into 10, I got 3. And finally, answer is coming with us is 0.3 kilogram. So I hope so. Question number 1 is very, very clear. Question number 2, students, particle P of mass 0.4 is thrown upwards from horizontal ground speed is 10. So it's thrown upwards. Launching speed is 10. Goes up. For greatest height means ultimately it will peak, stop on peak. Stop means it means ultimate last velocity is 0. Going upward, gravity -10. And we're looking for the height. So not a hard job. So 2as or 2gs v squared minus u square. Gravity -10, s we need to find last velocity 0, u is 10. So s I'm getting here -100 and -20. So we got a 5-meter distance. So first part is very easy, nothing hard. Part number 2, when P reaches the ground again, it means it will go up and comes down. Okay, what happens? At the first instant, it hits the ground. The loss of the particle energy is 7.2. So let's have a look now. So now particle first, it is coming down. This is the first hit. So U is 0. So that's not our concern. But thing is that when it's when hit, okay, it rebounds and goes up and stop on the peak here. This stop. And then it will fall down and comes down. Okay, so naturally, I just make it this diagram slightly right side. Okay, it's very clear, students. The time is going upwards and downwards same. This is not a problem. So problem only the one important part, student. What is the important part here? Is a loss. This hitting and rebounding. So this duration, this one, the loss in kinetic energy or not energy is 7.2. So I can say here, this is I'm giving as a V1, okay, or V account. This is I count as a U, okay, and or I count V1 and U1, no problem at all. So this velocity and that velocity, okay. So it means that we need to find this velocity as well. So let's try to look here. As is 5 meter, we have it. These are 5 meters. U0 and gravity is positive 10. Though we have it, I think it's let's try to do it. Although it's coming easily, 2gs is equals to v square minus u square. G is positive 10, s is a 5 meters, u is 0, and we need to find. So this is becoming 10 and the same. Okay, it means we learn from lesson from here. So what's launching speed? Same speed is just reaching ground again. So this is a 10, so it means this speed is 10. I'm writing here, okay, I'm leaving as a v only, no problem. Now students, is very clear. So what we can say, have m, this is naturally smaller, this is bigger. So I'm saying here have m v square minus half m u square is equal to 7.2. Repeat my words. So this is speed, we have at 10, so we can plug in mass is I think given on top and 0.4. Half into 0.4 into 10. So this is our energy just before hitting. Okay, and this is energy 0.4 into u square, okay, is equals to 7.2. In this way, we can find out this u easily, okay? Or I call as a u1, no problem at all. So now matter of typing in calculator. So half into 0.4 into 100, I'm getting here 20 and here 0.2 u1 square and equal to 7.2. Okay, this goes there 0.2 u1 square and 20 minus 7.2. So after this one, if I subtract and divide by 0.2, and I'm getting here 64, and ultimately I'm getting here, so u1 square is 64, and I'm getting here 8 meter per second. It means when it's going upwards, it rebounding, the speed is 8. and top velocity 100% zero, so V1 and U1. So we have the V1 and U1, I got it, and going upward gravity -10. Problem is we need to find two things here, and that is, sorry, we can find easily 2GS. I think we can find out easily time. So V equal to U plus GT and 1. So last velocity 0, U1, I just got 8 students, and gravity going upward -10. So I got here 0.6 second. So 0.6 second is this time, and into 2 because this time is remain same. So total time is 1.6 second. I think the point is very clear, and the concept is very clear, and question is completely over. Question number 3, students, we have, and particle starts from rest. Okay, it means when time is 0, S is 0, and V also 0. Okay, and displacement given, no, S is not 0, but V is confirmed 0, because V is confirmed 0 because start from rest. Okay, you may ask why not S0, because if plug in time 0 times S becomes 6. So it is up clear. And now, so find out the S when the particle is at rest. Okay, find S when the particle is at rest, and rest is only possible when velocity is equals to 0. So do we have this velocity given? Not at all. We have to go for, we have as lowest level displacement. If we differentiate, we get the velocity. If we differentiate again, we get acceleration. So differentiate and differentiate. If I come down, integrate and integrate. So right now I have a displacement level, I have to differentiate. So if I differentiate this one, so students, I get velocity, and 5/2 comes down and power 1 less, so 3/2. And this as it is, 3/2 comes down and power 1 less, half, and 6 becomes 0. So after this, what to do? We have to plug in velocity is equals to 0. So 0 and 5/2, and this is 15 twos are, this is a power 3/2, and 15 threes are 45 over 8, and t power half. And what is the way to get it? Half, and 3/2 is the bigger one. So I will take t common out, because you know, if you check it here, 3/2 is basically half plus 1. So it means this, we have a 2 powers, half and 1. So half common, so I will take it half common. Half power out. So I get here, students, 5 over t, and here this totally went out. So now this is 0 or this is 0. So first time is not possible. So 5/2 time to t minus 45 over 8 is equal to 0. Get time from here. So 45 over 8 and times to 2 over 5. So, so 45. Okay. And this answer is becoming with us, its time is coming with 9/4 seconds. It means particle stops when time is 9/4 seconds. This is time is clear. Okay, now student, I have to plug in simple in back in equation and get the displacement, because he was asking displacement. So particle is, okay, find out the value of S. So T is 9/4, and power 5/2, and 15/4, and 9/4, sorry, power is 3/2, and plus 6. So it's a matter of typing in calculator. So power 5/2 minus 15 divided by 4 into, so 3 divided by 2. So answer is coming with me if I type all together. So 0.9375. I hope so. The concept of the question is completely clear. Question number 4, students, we have the velocity of a particle t seconds after leaving fixed point O, And diagram shows a velocity time graph which models the motion of the particle. The graph shows 5 straight line, 1, 2, 3, 4, and 5. All right, and acceleration is the particle accelerates to a speed of 0.9. So this speed of 0.9 it gains in 3 seconds. Okay, then constant speed for 6 seconds. This is 6 seconds. So constant speed. All right, and he said it come to rest after 1 second. So 1 second is rest. The particle then come back. It's been, student, when a positive velocity, this area is going away. The particle is going away. This is a distance. Okay, and this is an area when it's negative velocity. It means coming back. I explained this is coming back. So I explained before many times. I repeat again. When the particle is going away from the observer velocity positive and coming back to observer velocity negative. So it's clear from this area representing that it's coming backwards. He's asking distance travel the particle first 10 seconds. So 10 seconds is this one. So I have to find out full distance going away. The trapezium formula. This is A value, which is gap of these number 9 minus 3. I got a 6. And B value is this number 10 because full gap is a 10. And height is a gap between them is equal to 0.9. You can see from here. Now trapezium area formula is half into H into A plus B. I'm going to plug in, students. 0.9 and A value is 6 and B value is 10. So there's 16. So 8 times 2.9 and we are getting 7.2. So distance traveled in first 10 seconds is 7.2. I think this part is nothing hard. So this is correct. Okay. And let's go for the next page. What we have, students. Given that t is a time for the find the minimum velocity of the particle. If t is capital 12. If capital is 12, okay, so let's see. It means if t value is 12, I will take a 12. I need to find out what, students? I need to find out this velocity. So basically, I'm looking for this height, okay? And that depends upon what? That depends upon what? Here, this main line, the particle moves back and return to the same point O. It means that distance traveling going forward and distance traveling coming backwards are exactly same. I think this part is very clear. So I'm going to solve now. So now return journey. Return journey is naturally same area. So area is equal to half into base into height. Area remains same. Reason is very clear. Going forward and coming backward, the distance is same. As he mentioned that it come to the rest or the O point again. All right. So area, I'm writing 7.2 and half into base into height. Base is where? 7 t minus 10. To t I have 12 and 12 minus 10 is a 2 gap. And height I want to find it. And that answer is coming with us is h is equal to 7.2. And that is basically velocity at this moment. So that is a negative. So we can say here velocity is turned to be negative 7.2. We are bound to put negative sign. Why? Because a particle is coming back. And I said before, and is below x-axis, that is why it's a negative 7.2. So this part is very clear. And now let's go for the last part of the question. It is given that greatest speed was particle is 3 now. I repeat what he's saying. Instead, the greatest speed of particle is not 7.2, not 3, he said. Okay, find the value of t and hence find the average speed of the particle for the whole motion. Okay, now go back on the diagram. So he said that if you look, or I can make a diagram here even, no problem. So situation is like this. This t is unknown. We need to find t, and this I think so 10. Okay, and he mentioned that the speed is this time is this number is 3. Okay, he said greatest speed is 3. He did not put negative sign. Okay, just for magnitude only. And now we can say that and t and find the average speed of the, okay, so this is not a hard job. So we can find it easily. Same story. We have area is equals to half into base into height. And 7.2 remains same because he said that let's return back same position. So base is this gap. Okay, I'm writing base as it is, and height is 3 because this gap is 3. And if I check it in calculator, so 7.2 into 2 and divide by 3. And we are getting here 4.8. We are getting here base equal to 4.8. And this is a 10. So what is this 10? So we can find capital T is equal to 10 plus 4.8. And we are getting here 14.8 seconds. So this part is clear. He was asking the T value, done. Hence the average speed of the whole journey. What is average speed of whole journey, students? That is average speed is a whole journey is so simple. Total distance by total time. Okay, so we have to find out total distance. First distance we have it, and that is 7.2 and 7.2. Yeah, 7.2 and 7.2, because 7.2 is the first area and 7.2 is second area. So total distance we are getting 7.2 plus 7.2 and divide by total time is what, students? Total time is 14.8, and we are getting here. We are getting 14 points. So 14.4 divided by 14.8. And answer is coming with us in fraction form. If we write it, so fraction form is coming with us 36 over 37 meter per second. Okay. And let me check. Did he ask for exact? No, not exact. If not exact, so we can give answer in decimal form. And decimal form is 0.973 meter per second. This is called average speed. I hope so. The concept of the question is completely clear. Question number 5 we have, and forces equilibrium topic. He's saying that the forces mentioned and says forces are in equilibrium. So we need to find F and theta. So first of all, resolve forces, and it contains some marks to make sure. This is theta angle here and F cos theta. And this is, students, very clear, F sine theta. And what about this? So this is a 60 degree. You can see from here. So I'm writing here 40 cos 60. And what above this one? 40 sine 60. And it has no components. Okay, now I can say that because system equilibrium, so right side forces is equal to left side force. So I'm writing here horizontal components. Okay, I'm writing F cos theta plus 10 equals to 40 cos 60. Repeat my words. These two forces acting right side and this force acting left side. So I can say clearly, so I have this 10 goes there and I got a F cos theta equal to cos 60 is cos 60. If you check it, cos 60 is a half. Half into 40 is becoming 20. So I got a 10. How? There's a 20 and negative 10. I got his first equation. Now I'm going for the vertical components. Vertical means these two sum is equal to this one. So I'm writing now here, and this is shifting slightly left side. So F sine theta plus 40 sine 60 is equals to 50. Now again, what is this one? This time is coming root 3. Basically is root 3 over 2. These two cancel. I got 20 root 3. So F sine theta. So 50 minus 20 root 3. Once again. Okay. So this is a 20 root 3. Correct. Okay. Question number 2 done. Now, student, how to get this one? So nothing hard because sine over cos is a 10. So what I'm going to do, student, second equation divide by first equation. So look, I'm going to show you. So I'm going to divide them. And what is the criteria of dividing, students? I will copy the first equation and same way I'll copy second equation. And this is done, students. And I'm shifting this is in like this, and this is here remain same. And these two equal sign I eliminate, and I put a one equal sign in the middle, like this. FF cancel, student. I'm getting here tan theta. And this I'm going to type in, calculate this as it is. I'm putting, and theta is equal to tan inverse 50 minus 20 root 3 over 10. And let's try do it. Okay, so when I take a tan inverse, students, I'm getting the angle here 59, 6.9 degree, 56.9 degree. And we have to find what, not this only, we have to go for force also. So how to get this one, student? But I have to write the long value, not 9 only, 93246. And this is a rounded answer, this one. But while using this answer, I'll use full answer here or here. I'm using in one equation. So I'll use exact, not exact long values, okay? So for accurate answer. So have a look, students. So I'm writing now f cos theta, but in the place of theta, I am using what? I'm using the long value 56.93246 equal to 10. And f is equal to 10 divided by cos of 56.93246. If I check in calculator, students, the answer is getting here 18.3 newtons after rounding. I hope so. The concept of question is very clear. And second part, students, he's saying instead the force we found, we have said no, use this values now and find direction and exact value of the force. So we have to take the f and theta, this one. So let's see now how we can do it. Okay, then we have to first of all, this diagram we need there. So what is the method, students? So this is F 40, and this is a 10. This is a 50. Okay, and now students, I just take this diagram on another page, and I'm going to solve it there. Only I will not copy. Okay, and I'm pasting here. Okay, students. Now, what is story we have? We have to take f as a 10 root 2. So 10 root 2 and theta also. So here I'm saying 10 root 2 cos 45. And what about this? 10 root 2 sine 45. This is done. Now I think we can finish it because we're looking for Rx. What is Rx, students? So this plus this and minus this. So 10 root 2 cos 45 plus 10 minus 40 cos 60. Okay, same way I can find Ry. How to find Ry, students? These two components acting upwards and this downwards. So I can say here 40 sine 60 plus 10 root 2 sine 45 and minus 50. So I'm going to find Rx and Ry. Okay. So values I have to plug in just in calculator. So I'm getting the first value Rx is, I think it is a Rx is coming with us 0. R is coming 0 with us. Okay. And what about the other force, students? Other force is we are getting, if we check it, sine 60. Okay, we can get exact values even. Did he ask exact? No, yeah, he said ask exact. So we have to plug in, and sine 60 type alone and time 60 is basically root 3 over 2. And 1 sine 45 is root 2 over 2. You can check in calculator. So this is becoming with us 20 root 3. And this is this root become 2 and 2 cancel out. I got a 10. And I'm getting finally 20 root 3 and minus 40. And I got a ry, students. Ry is confirmed. Now, if you check it in this one, this value, just take off because he's asking direction also. Yeah, direction as well. So just type it because I want to know is a value in magnitude also. So I'm getting ry is equals to negative 5 point something. Okay, you know why I found it? Because it mentioned that ry is going downwards. So I can say because rx is 0, r and x is 0. So I'm using Pythagoras theorem. And what is the Pythagoras theorem? R square equal to rx square plus ry square. But if rx is 0, so then what will happen, students? So ry square, take a root. So resultant is basically r value. So this is the same resultant value. And I got resultant value, which I'm writing now here. So this is the resultant value in newtons. And what is the direction? Direction I can tell easily. Direction is along negative y-axis direction. Along negative y-axis. Why negative y-axis? Reason this negative sign mentions here. So we can say here is direction towards negative x, or you can say it is acting below, okay, with a bearing concept, you can say, or you can say and 50, yeah, we can say 52, or we can say along 50 Newton force. How come? Because if you look at here, this 50 Newton force. Same story, direction in along is along y-axis, negative y-axis, or along 50 Newton force. So both concepts are correct. We can give any direction, no problem. I hope so. The concept is. Question number 6, students, we have two particle PQ, masses is 0.2, you can see 0.1, you can see, and string passes of fixed pulley, smooth pulley. Pulley is always smooth in our syllabus, and P lies on smooth plane. So this is smooth, so friction is equal to 0. All right, and Matthias mentioned further, 60-degree, and Q lies on plane BC is inclined. Hold on, let me check again. Is a rough or so P is smooth, that is correct. P is smooth. And Q lies on a plane BC which is inclined an angle theta. Okay, particle can move on the line of slope. Okay, theta is 60 now, we take 60. And BC is rough, so this here friction is not equal to 0, make sure. And coefficient is given 0.7, and we need particle release from rest. It means starting velocity is 0, and we have determined the particles, determine whether particles move or not. So let's try to do it. I think so we can start from here first of all, check it. Okay, what is the component breaking? This 0.2 into 10. So this weight component is acting is 2 newtons. And what is this, students? So this is a naturally 2 sine 60. And tension towards pulley, that's for sure. Okay. And what about this? And this no need to make. Why R component no need to make? Because friction is 0, so no need to make. Okay, now let's try to do it. So, and what about the other part? Other part is, we can say, this is, what's the mass? 0.1 into 10, 1 Newton. This is a 1 Newton, students. And this downwards is, I'm writing here, 1 sine 60-degree, because he has given, I think, let me check. Yeah, 60 given. So 1 sine 60. And what is the R component? R component, we can make it. This is coming with us 1 cos 60. And tension towards pulley. And because what he mentioned there, and he mentioned the particle, okay, rest, determine whether particles move or not. So first of all, he's saying here, if you read a statement before, 1 minute please, Q, okay, string is taut, particle move, line, okay, all right. And coefficient, friction, and BC plane 0.2, okay, particle release. So let's start from here. So let's talk about P particle. What's formula? Net force equal to ma. So it is, let's say, if it's moving downwards. So if it's moving downwards, what happens? Because it's a heavy particle, it's moving downwards. So I can say here 2 sine 60 minus tension is equals to MA, and that is a 0.2 times 2A. Same way I can go for Q particle. Let's talk about this one, but friction is downward. Look, I write friction also. And that is F is equal to mu R. Mu is 0.7 and R is what, this one. So I'm writing directly into cos 60. So now I'm starting, because system moving upward, how come this moving downwards and this goes upward? So tension is bigger and these components are smaller. So I'm writing here tension minus friction, which is, okay, I can find friction value directly, no problem at all. So 0.7 times 2 cos 60. And cos 60 is half, so basically I'm getting 0.35. So 0.35. Okay, now I can do it easily and I can make directly here, no problem. Tension minus friction, which is a 0.35, minus weight component, which is sine 60. It means sine 60 and is equal to MA. And what's the mass? 0.1 times 2A. So what I will do, students, I will plug in T value and get the acceleration. So I think I will, if I make it, bring it here and bring on the other side. So I will get what, student, from here? So 2 sine 60 minus 0.2A is equal to T. This T value I'm going to replace here. So put in the second equation. So what I get? So this whole thing I'm going to replace here. So 2 sine 60 and sine 60 is root 3 by 2. Root 3 by 2. These two cancel out. So this comes in the place of t, negative 0.35, and sine 60, again same thing, root 3 by 2, equal to 0.1 acceleration. Okay, I'll bring this part on the other side. And what I get, 0.3 acceleration. And now I'll type this in calculator and let's see what answer comes. So root 3 minus root 3 divided by 2 and minus 0.35. And I'm getting the answer is coming with us. So I'm getting this answer 0.516025 and divide by 0.3. It means I have acceleration value 1.72. And whenever we have acceleration value, students, it means that particle are in motion. And he was asked just only confirm that particle is moving or not. So we can say here, so it means the particle move. I hope so the point is very clear. And let's go for the next part. Second part we have, student, it is instead the particles with BC is smooth. It means first both were rough and now both are smooth. Okay, BC is also smooth. Let me check again. BC is yeah, correct. Both are smooth then now. And particles are released from rest in the subsequent motion. Tension string is given here. So I'm going to make this diagram here. Here 60 given, but I think so here this is theta to find out. And pulley here, and one particle is placed here, and one particle is placed here. Okay, and this is a 0.2. This is a 2 newtons downwards, and this is 2 sine 60. And this is a 1 Newton downwards, and this is a 1 sine 60 or sine theta, sorry. Okay, now this is now both smooth. No need to make R components. Why? Because both are smooth. Okay, that is what tension towards pulley for sure. And he said that tension is given by him. Okay, and particle reached from rest, it's moving, and find magnitude of acceleration P. It moved the plane. Find. Okay, so let's start. This moving downward, students. So 2 sine 60 minus tension is equal to MA. Okay, tension is given by him, so I'm using 2 sine 6. Sine 60 is root 3 by 2. And tension I'm writing in bracket, this one is equal to 0.2A. Okay, this is done, and after this is okay. And open the bracket, I got 1 minus root 3 equal to 0.2A. And from here, I can find out the value, and 1 minus root 3 divided by 0.2. And I'm getting here I'm getting the value. So value is coming with us. Let me check once again. So 2 sine 60 minus tension is equal to MA. Maybe let me check. Oh, sorry, I missed this root 3 part. Basically, here root 3 part. Now I check again. Root 3 comes from here and minus 1 and minus. Okay, this is a minus plus 1. Now this is clear. And I got this one, students. Okay. So and it means this. I have a 1 here equal to 0.2a. And 1 over 0.2 is giving us 5 meter per second square. So this acceleration is clear, student. Now I'm going for the theta. And common sense, this is falling downwards, so it will go upwards. I'll start from tension. So let's start. Now particle other one. So I can write now here tension minus weight component is equals to MA. That is a 0.1 times 2A, and that is a 5. And tension we have already. And what is that tension? Tension value is root 3 minus 1 minus sine theta is equal to 0.5. I'm looking for sine theta. Sine theta goes on right hand side and this will come left side. So I'm writing here root 3 minus 1 and minus 0.5. So, so if I check it, theta is equal to sine inverse and 0.23205. And when I take sine inverse, students, so angle is giving us 13.4 degree. I hope so. The concept of question is completely clear. Question number 7, students, we have a car of mass 1200 kilogram. It's traveling along a straight horizontal road. The power engine is working constant equal to this much power given. And the constant friction more is given here 500. Find acceleration of the car instant when speed is 20. This is not a hard job, students. This part, inshallah, easy, I believe. Applied force, friction force. And what formula we use normally for this kind of questions? Net force equals to MA. Applied force minus friction force is equal to MA. And we have a power formula. What's power formula? F into V. If I bring V under it, so I can say that power over V is equal to F. So this value I'm going to replace here. So power is how much? 1, 6, and 3 more zeros. Reason kilo. Okay, and speed is 20, friction force 500, mass 1200, acceleration we need to find. Now rest part is just typing in calculator. So here I got 800, I got a 300 and 1200, and I'm getting 00 cancel, so acceleration becomes 104 meter per second square. So I hope so. First part is very clear. Okay, part number next, students, we have, if you look down, part number next, he's saying here, assume the power and the resistance force unchanged. Okay, and steady speed. So what is steady speed, student, means? Steady speed means acceleration is 0. Okay, which car can be travel? So find out the steady speed. So same story, students. Same story I will use. Okay, I'll use same formula. So I'm using same formula, students. You know it very well. So power remains same, 16,000. Over speed unknown, friction is 500, and acceleration is 0. And that's it. 500 goes there. And 00 cancel out. So 160 is equal to 5 times 2V. And V becomes, so 5 3s are 15 and 32 meter per second. I think the point is very clear. So this part is clear. So let's go for the next part. Last part, okay? The question is here, car comes to the bottom of a straight hill of a 3 1 meter. Okay, it means per car is traveling horizontally and then it will go on an inclined plane. Okay, so car comes to the bottom of the straight hill of the length 316 meters, inclined angle this much. Okay, so I think we have to make a diagram. Okay, and this angle I take alpha, and alpha is equal to that one. So alpha is equals to, so I can say that alpha is equal to sine inverse 1 over 16. If it goes there, so it becomes sine alpha is equal to 1 by 16. Okay, this I can use if I need. The power remains the same, so power remains same. So 16,000. And friction no longer is constant, changes such that work done against friction force is this much. So I'm writing now here work done against friction force is 128 and 400 joules. And time taken for to ascend is 15. It means going upward 16 seconds. So given that car is traveling speed of 20 to 0 at a bottom, so velocity speed I had 20. And at top of hill, find speed at bottom. So I have to find out the speed at the top. And if I make it this kind of triangle, so I'm going to apply magic formula. How to apply magic formula, students? So all data is enough to apply magic formula. So have a look now. First of all, let me write magic formula and then explain to you everything. So work done by applied force minus work done by frictional force, kinetic energy plus potential energy at an end point is top. And potential energy at a starting point B for bottom. And I think you can see we have all values given mostly and few missing. So let's try to find it. And how to find work done by applied force? Because we have formula, we have, if you know it, the power formula is what? Work done by time. And power and time, we have both values. So I'm writing here power is equal to work done by time. And I can say work done by applied force is basically power times 2, 16,000 times to time. I think idea is very clear. So 16,000 into 15, and I'm getting here 2, 4, and 4 zeros. Joules. I have it. Now, work done by applied force, we have it, students? Yes. And this we have it correct, okay. And one thing left only, and potential energy at bottom is 0 because 0 height. Only thing left is a height. And I'm going to find that height first of all. So let's start, students. I'm going to find that as well. So what is I can apply triangle method. And what is the distance of the hill is 316. So 316. I at this alpha I have it. Opposite by hypotenuse. So h over 316 equal to sine alpha. And sine alpha, I said before, we have sine alpha 1 over 60. So 1 over 60, and if I bring it here, so 316 into 1 over 60. So 316 divided by 60, I'm getting here in fraction number, or I can, no problem. Fraction number, I'm getting 79 over 15. Now, students, I can find it potential energy and all these things. So let's try to do it. Okay, have a look now. So what left here? Potential energy at the top, mgh. What's the mass, students? On top is given mass. I think we'll go back and see the mass. Mass is 1200, 1200. Mass 120. So 1200 mg and h. H is, I got it now, 79 over 15. And times to what? 1, 2, and triple zeros. And I'm getting here 63200 joules. And I think, students, now what left behind? Only kinetic energies. If I find separate, I can plug in the values. Let's start a kinetic energy. So kinetic energy at a bottom, half mv square, mass 1200, and v is 20. So 600 times 220 square, and I got it 2, 4, and 4 zeros. Okay, now I can plug in the value, students, and question is about to finish. So what is applied force? This is, I got it. 1 minute, let me check again. 16,000 into 15. Yes, so I got this 2, 4, and 4 zeros. And this is, I have it already. You can see on top 128 and 400. And kinetic energy on top, I need to find it. So I'm leaving as it is. And potential energy we just found it. So 6263200. And Ke at the bottom we have, and that is negative 2, 4, and 4 zeros. And potential energy at bottom is 0, no need to type. Okay, now student, I'm going to make a K separate. So 2, 4, 4 zeros into 2 and minus 1, 2, 8, 4, 00 and minus 6, 3, 2 and 00. So I'm getting here 2, 8, 4, 00. And what is K? Half mv square, mv square. So this, it means divide by 600 and take a root of this. So I'm getting here 21.9. So I'm getting this answer, students, 21.9. I hope so. Concept is clear and this question is completely over. Paper is completely done, students. So best of luck for your upcoming exam and pray for me. Assalamu alaikum wa rahmatullahi